Okay, folks, last video, let's jump into non-parametrics. So I have to be honest with you. In the past, we have generally taught that there are no non-parametric equivalents for bivariate or multivariate linear regressions. But as I've done some additional research in preparing for this term, we really started to realize that there were two possible solutions that we can explore, one being the Kendall-Thiel procedure and the second being the kernel regression. I will tell you, I will not expect you to be able to actually have skill sets and do these statistics this term. I just want you to be aware that these things exist as non-parametric friends or equivalents for linear regression, but these types of procedures are covered in a little bit more detail in our advanced statistics course. So if you're interested in learning more about these procedures, I would encourage you to register for that class. The first of these two is what's known as the Kendall-Thiel statistic. And the key distinction between Kendall-Thiel versus kernel is that with Kendall-Thiel, the predictor, the X predictor, does not have a predetermined form, meaning sample form, standardized score form. But the process and the thinking between how it's used is rooted in linear regression. The nice thing about this kind of procedure is that it's what's called robust to outliers. So even if you have some variables that are 2 and 3 standard deviations beyond the mean, it's throwing your scatter plots off, it's robust to having those data included in the analysis, meaning having the outlier doesn't significantly throw off the degree of the line of best fit in a Kendall-Thiel statistic. And the reason it's capable of doing that is because it's going to compute the lines between each pair of points, meaning the XY coordinates, and it's going to use the median rather than the mean of the slope of these lines. And remember, the median is a better tool when we're trying to estimate things when we have outliers in place. And the problem was that we didn't really have a way of using the median to generate a line of best fit before this Kendall-Thiel procedure existed. But as statistical analyses and as statisticians move forward and try to use these types of procedures in the real world, these types of newer techniques have been developed. So Kendall-Thiel is nice because it addresses issues with outliers and uses that median to generate that line of best fit. The other type of non-parametric statistic, therefore, is what's known as a kernel regression. And so in this type of analysis, this is going to estimate the conditions or the conditional expectation of a random variable. So whereas in linear regression and in the Kendall-Thiel non-parametric statistic, for example, we're using things that we expect based off of a fixed assumption. And so if there is not a fixed assumption and we have some level of randomness going on, kernel estimates that Y variable of interest randomly. So it's not based off of fixed assumptions where these conditions need to be set in order for this to work properly. But the goal is really to try and find a non-linear or a curvilinear relationship between X and Y. So rather than having it sort of be this solid line of is X related to this solid line, in a kernel regression, it understands that there might be different shapes and movements in that line, and do the shape and movements of that line tend to move together. And so it's not a fixed line. It has some level of flexibility in how it moves. And so when we have a ton of data points and lines are not perfectly linear, a kernel regression is a really nice non-parametric tool to back us out and save us from violations of parametric assumptions for traditional linear regression. And the way that it does this is that it estimates the weighted sum of all observed Y values of interest given X, and it scales it between a 0 and 1. And the intersecting line that is perpendicular to the X-axis given a value for X. And so this graph really is just conceptually trying to demonstrate that we do not have a solid linear assumption, that the data points can generally move, and as one variable moves curvilinearly, so too does another variable, and that demonstrates a relationship. And so, I don't expect you to be experts in the kernel regression nor the Kendall-Thiel non-parametric regression procedure. I just want you to be able to recognize that these are non-parametric tools that we can use to help salvage our data for linear regression if the basic assumptions for regression are not met. So I hope the series was helpful. Of course, if there's any questions that people have, I welcome you to come to my office hours or to come to class so we can dig in and go through some of these concepts in a little bit more detail. But I hope as you sort of round out the rest of the term here, you really appreciate just how much you've learned this term. We started off knowing little to nothing about the research process, and you now understand the difference between independent versus dependent variables. You understand scales of measurement. You understand basic assumptions. You understand a whole basket of tool sets and how to use Excel and calculate things yourself in Excel, how to verify those types of things in JASP and SPSS, how to know how many people you need for a research study for G-Power, and then how to determine when I'm giving a particular research setting, what tool out of all these tools that we learned this term should you choose to effectively answer your research question. And really, that's what it's all about. That's what this class is all about. You may have liked the computer side of things more than the statistics side of things. You may have liked the Excel part of things more than the research side of things, but you now have perspective and a wider worldview on just how we integrate all of these knowledge, skills, and abilities, regardless if you're in the nursing profession, regardless if you're in the health professions profession. And I hope that I had the ability to play a very small part in that. So, of course, if there's any further questions, feel free to bring them to class. Thank you all so very much for a great academic term, and I wish you all the best in your futures. Take care.